So today we've talked about action potentials, we've talked about how they go through the neuron, and now we're going to talk about what happens at the synapse. So we're here, we're at the end of my axon terminal. What is going to happen here now that my action potential has gotten here? There are kind of two variations. The first variation is what we refer to as an electrical synapse. And in an electrical synapse, we have gap junctions, right? So where I've got my cell, and it's fully connected, right? My cytosol is completely connected. And so in that case, the action potential is actually just going to keep going. Those ions are just going to keep on flowing all the way through to the next cell, and it's going to elicit a response. These are not very common because I don't want my body responding to every single signal with the same intensity and the same speed all the time. My body needs to process and think and do things like graded potentials. So what we usually use is a chemical synapse. And a chemical synapse is when we use a neurotransmitter. When I use a so how do we get that neurotransmitter from one side of a cell to another? And I'll have it talking from this axon, this neuron, to, let's say, another neuron. This neuron at the front, where we're getting our action potential from, is called the presynaptic neuron. And the one at the end is the postsynaptic neuron. And so the signal is going to go from presynaptic to postsynaptic. You will see a potential. I'm going to see a change in voltage in my presynaptic neuron first, and then I'll see a change in my postsynaptic neuron. The presynaptic neuron is going to have that action potential, and so it's going to usually be a positive change. And then the postsynaptic neuron can be either positive or a negative change, depending on if I want to make the cell more positive or more negative. Okay? So what happens? What happens is the action potential, so the ions are going to be flowing down the neuron. And so that positive charge, that depolarization from the sodiums that we saw, are going to eventually reach down at the bottom. And we have at the bottom a calcium gated channel. The calcium voltage gated channels are sensitive to this positive change, and so they open up and allow calcium to rush into the cell. When calcium rushes into the cell, it causes many different chemical reactions, but namely, it is going to facilitate neurotransmitters being brought to the surface. And when they are brought to the surface, their synaptic vesicles that they were hidden in will fuse to the plasma membrane and allow for them to go across. So they're going to be exocytosed. Then that neurotransmitter can go and bind to a ligand-gated channel on the next neuron. This causes, either a positive charge to go in, a negative charge to go in, positive charge to leave, what have you. It's typically one of those responses, but it's going to cause a graded potential. If I want my neuron to cause a major response in the next neuron, I'm going to need many, many neurotransmitters binding to many receptors, not just one. And then, over time, eventually the signal needs to stop. When the signal needs to stop, these neurotransmitters typically are going to be either recycled or broken down or absorbed by glia. It depends on the neurotransmitter. But anyway, I hope this helps with understanding the steps of what happens at a chemical and electrical synapse.